the district benchmark test. That is your second test that's due on Tuesday. Okay. It should also help you with the geometry, with the circles test. But if we start with Unit 1, what do I need to know from Unit 1? All the logic stuff. So are we good on the symbols? Do we need to talk about the symbols? The and the or. So that's and that's or. Yeah, absolutely. I'm going to give you 2 just in case you need them. Anybody else need some paper? The or is the V, and the and is the one that is the A without the crossbar. Right? That's how I remember it too. Otherwise, I'd be lost, right? We know conditional, converse, inverse, and contrapositive, right? These 4, the conditional is P to Q. The converse changes the order to Q to P. The inverse keeps the order but puts in a not. So not P, not Q. And then contrapositive, we change order and not. So that's not Q to not P. When I ask you valid and not valid, 2 of those patterns are valid and 2 of them are not valid. Still, lots of people, when they see a valid and not valid question, they're reading for truth. Don't read those words for truth, read them for patterns, okay? The conditional pattern, if your statement is asking valid and invalid, if it ends P then Q, that is valid. If it ends not Q, not P, that is valid. These 2 here, not valid. Okay, if I have a series of logic statements and they start with Q, you cannot give me P. That is not a valid answer. If it starts not P, you cannot give me a not Q. These 2 patterns are not valid. Okay, those are the hardest questions, those valid, invalid questions. Anything else I missed in logic that we need to know? So the if then is the conditional. This is the if then. The if and only if, I did forget. Biconditional. Is the 2 arrows. Okay. Biconditional if and only if. I feel like we're really good at logic. You will get every single easy question on logic. You'll probably get almost every single medium question on logic. And to be perfectly honest, the hard level logic questions are so hard that it won't matter how much we practice them. They're just stupid hard, right? Sometimes there are. Every once in a while, there's one hard logic question, and it will be like, what the heck are you even asking me? It won't be like anything that I've given you. What about Unit 2? All this geometry basic stuff. This is all the formulas with X and Y. So what's the midpoint formula?
Isn't it X plus X?
And then Y plus Y over 2. That's midpoint. What about endpoint? What if I give you an endpoint and a midpoint and I want the other endpoint? So if I have the two endpoints and I want the midpoint, I find the average to find the middle. If I have an end and a middle, what do I do to find the other end? You do the table. And what has to go in the middle of the table? The midpoint, right? So you put your X's on the left and your Y's on the right. The midpoint has to go in the middle and the two endpoints go on the end. I mean, it just kind of makes sense. You just have to know how to organize it, right? So we've got 4 formulas with X's and Y's. The midpoint, the endpoint, then we've got distance. What's the distance formula? X minus X squared plus Y minus Y squared equals the distance. X minus X squared plus Y minus Y squared equals the distance. Okay. That is super similar to the circle formula. The circle formula is on your formula sheet. The circle formula is exactly the same formula, except it's R squared instead of the square root. And it's got X minus H squared instead of X minus X. And Y minus K squared instead of Y minus Y. This formula is on your formula sheet. They are almost identical. They're both derived from the Pythagorean theorem. Okay. What am I missing? I've got midpoint, I've got endpoint, I've got distance. What? Bisect. So what does bisect mean? Absolutely. So I'm going to divide by 2, whatever it is. I'm going to divide it by 2. That's bisect. What's my other formula that shows? I'm going to make that another color so it's easier to see. Whatever it is, divide by 2. Bisect means you divide stuff by 2. What's the other formula that we have that has X's and Y's in it? Slope. Slope. I don't know what it was first term because I felt like my students really knew slope. Slope is rise over run. But over 50% of them missed the slope question on the SOL. So I don't know whether the slope question was worded oddly or whether they overthought it, because I get to see what the results were and how hard the questions were. And it didn't look like it was a hard question. So Y minus Y over X minus X. Make sure you know slope. Y minus Y over X minus X. My guess is they just didn't realize that's what they had to do. Okay. Y minus Y over X minus X is rise over run. And it's hard to keep all those X's and Y's, pluses and minuses straight. If you want to screen capture it, screen capture this. I'm going to go to the next slide. Hopefully, again, you're writing it on a piece of paper. There is definitely memory retention between your brain and your hand when you write things on paper. All right, Unit 3. What do I need to know about parallel, perpendicular, and all these angle relationships? What's the difference between parallel and perpendicular? Parallel never intersects. Perpendicular is going to intersect at a 90-degree angle. Absolutely. What about their slopes? Parallel lines have what kind of slopes? Same slopes, equal slopes, right? So parallel lines have equal slopes. Perpendicular lines have the upside down reciprocal. So if I have a slope of 1/2, how do I make the perpendicular slope? -2, and that's going to be over an invisible 1, right? So perpendicular slopes, upside down reciprocal. 1/2 turns into -2/1. 3/7 would turn into -7/3. Perpendicular slopes. Perpendicular is that upside down T. I just put that little right angle thing in it. Do that. Then we've got a bunch of angle relationships. Which one of these angle relationships are congruent and which ones are supplementary? Corresponding is like a slide. So if you look up above Dalton's head, the corresponding angles are the blue ones. So like the blue in quadrant 4 goes down to the blue in quadrant 4. Corresponding is like a slide. So corresponding is going to be congruent. What about linear pairs? If two angles form a straight line, what do they add up to or what do they equal? 180, absolutely. What about vertical angles? They are the same. Vertical angles are always equal. What about alternate interior? That's like the Z. So if I can make a Z with parallel lines, those are the same. So all alternate angles, whether they're interior or exterior, are congruent. What about same side interior? So if I've got same side interior, that's obtuse plus acute equals 180. Obtuse plus acute equals 180 every time. Acute equals acute and obtuse equals obtuse. What about adjacent? Is there any like specific relationship between adjacent angles? They're just next to each other. They're neighbors, but there's no mathematical relationship. So adjacent is like if I give you a parallelogram and I bisect, I do the diagonal, this angle and this angle are adjacent, but they're not necessarily congruent and they're not necessarily bisected. If I give you a square and I do the diagonal, then those adjacent angles are congruent because the diagonal bisects the angle. So adjacent just means they're side by side. Adjacent means they're side by side. They share a ray or a segment.
So they're angles that sit next to each other?
I think of adjacent like townhouses or apartments. They share a wall, whereas freestanding houses are not adjacent because they don't share a wall. Same side interior and same side exterior equal 180. Same side supplementary. Alternate is always equal to each other because that's the Z. So alternate, you can make a Z. Acute equals acute. Okay. How about triangle basics? Over here, what do I mean when I say triangle sum? What are all the angles of every triangle add up to be? In an equilateral triangle, they're always equal to 60. In every single triangle, what do the angles add up to? 180. I didn't even put isosceles and equilateral on here. I should have. What do I mean by triangle inequality or the hinge theorem? We add them and we subtract them and we want everything in the middle, right? So that's a subtraction. You want to subtract your two numbers and you want to add your two numbers and then you want everything in the middle. Triangle inequality. Subtract to get the smallest, add to get the biggest. So if you've got two things, you're subtracting and adding to figure out what can close that triangle. What am I doing when I do small plus medium is bigger than large? What question am I asking? Is it what kind of triangle? A regular triangle. This is the answer to, is it a triangle? Is it a right triangle? If I say, is it right? Then I've got to do a squared plus b squared equals c squared. They're two very similar questions, but if I just say, is it a triangle? Small plus medium is bigger than large. Is it a right triangle? Then it's Pythagorean theorem. So you got to read carefully to notice that right. guys got to let me know if I'm going too fast. What am I doing if I do small is opposite small, medium is opposite medium, and large is opposite large? Which one's the longest? So I'm ordering sides and angles here, right? If you're only given 2 angles, always find the third angle. That's like number 1. Remember, triangles is the whole middle part of your test. So once you get your first triangles question, you'll have about 15 of them. And then once you have no more triangle questions, you won't see any more of them. That's the middle of your test. Small is opposite small, medium is opposite medium, large is opposite large. That's ordering the sides and angles. So we're ordering. The next one we haven't hit on a lot. If I have a triangle and I have an exterior angle, so this is my exterior angle, then I've got 2 interior angles that are not adjacent to it. So I've got 1 exterior angle in a triangle, and then I've got 2 interior angles that are not adjacent to it. Inside plus inside equals outside. Inside plus inside equals outside. A lot of times you can back into this with triangle sum, but sometimes they get tricky and they put expressions in here and you have to set up an equation. Inside plus inside equals outside. These 2 inside angles don't need to be the same. They can be different. So if I tell you this is 100 on the outside and this is 55 in here, what's that missing angle? 45. Inside plus inside equals outside. And that's kind of a special one. So again, I'm hoping you're going to take all of these notes, make them your own, study them over the next couple of weeks, and especially use them on this practice SOL that I'm giving you that's due on Tuesday. Okay, so if you're not taking these notes, I really strongly encourage you to. Any questions on units 1, 2, 3, and 4? Dun, dun, dun. No questions. All right, let's go to this one. This one is just memorized, folks. Congruent triangles are exactly the same size and shape, and we need to know side, 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 angle, 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 side, and hypotenuse leg. Take your time, mark everything you're given on these questions, and then see what shakes out. And if you're at home and you have questions, comments, concerns, anything, just put it in the chat, okay? Congruent has that squiggle above the equal sign. Similar does not. So you got to pay really close attention to those symbols. As soon as you see that similar sign without the proportion, without the equal sign, you got to think, you got to set up a proportion. Remember, sides go in proportions, not angles. Sides go into proportions. Angles equal each other. Okay, in similar triangles, sides go in proportions. X over Y equals A over B. Small over large equals small over large. But angles equal each other. I'm sure your hands are starting to hurt at this point. It's probably been a long time since you've written this many notes. I know my hand would be hurting. Mr. Krikorian gives a lot of handwritten notes. Oh. Wow. Yeah. That's good. What's Pythagorean theorem, folks? A squared plus B squared equals C squared. The only thing Pythagorean theorem can help you with is sides of right triangles. It's the only thing Pythagorean theorem helps with. It is very useful, but it has one purpose and one purpose only: finding sides of right triangles. The triangles have to be right. Somehow that escapes a couple of people every year. With trig, we've got SOHCAHTOA. We know that the O's rise to the top and the H's sink to the bottom. The O's rise to the top, the H's sink to the bottom, and then the A's fill in the gaps, right? So when we make our fractions, it's always O over H, A over H, and O over A. SOHCAHTOA helps you with that. This is on the formula sheet. I'm going to show you in a minute where that is. Trig will help you find a side if you are given an angle. You have to be able to you have to have an angle in order for trig to work. Inverse trig is going to help you find an angle, right? This is when you're looking for an angle. What's the little symbol we have to remember? -1, absolutely. So for inverse trig, we got to use that -1 instead of that degree symbol. So if I'm using sine, I can do sine x equals O over H. If I'm trying to find the angle, I do sine inverse or sine -1 O over H equals X. So use this to find the side with the angle and use this to find the angle with the side. We're rocking and rolling. You ready to go to the next one? All right, our favorites, polygons. Woohoo! There were so many formulas. You just have to write all of these down. There's no other way around it. I know. I do need to change this one though. This is 360 divided by the number of sides. So let me change this one. My typed notes are 4 pages for all the formulas. Yeah. All the formulas for geometry, mine typed are 4 pages. This is like the Cliff Notes version. Those problems are fun. Dang. Remember, interior plus exterior equals 180. You got to read these words carefully. The total of the interior is n minus 2 times 180. Each interior is n minus 2 times 180 divided by n. Then the total of the exterior always, every single time, is 360. The total of the exterior angles is always 360. It never changes. If you can find the exterior angles, that is so much easier. 360 divided by the exterior angle is going to give you n. And then 360 divided by n is going to give you the exterior angle. So 360 divided by the exterior angle equals the number of sides, and 360 divided by the number of sides equals the exterior angle. That's these last two. You did. Although you might have done it, usually it's like a shape underneath so you can't see it all, and you might be able to just visualize all of the sides and use your method to estimate. Some people are really good at that. If I know the circle center is HK and the radius is R, I can write that circle, right? X minus H squared plus Y minus K squared equals R squared. Remember, the end of the equation is squared. Remember, the circle center and the equation have opposite signs. So if you have a positive H, you need a negative H. If you have a positive K, you need a negative K. They got to be backwards. Yep. And that's on the formula sheet too. This weird little thing right here, that's your Greek letter theta. So this is the angle divided by 360. And then remember, if you're looking for arc length, you use C. And if you're looking for sector area, you use A. Yeah, the theta is an angle. So it's a Greek letter that in math always refers to an angle. We use it in trig, and you'll use it next year too. So it's just a circle with a line through it. It's a Greek letter. Central and inscribed, we liked. Those were easy, right? Central angles meet at the center of the circle. They're like the ones between Wesley and Candace, the central angle and the inscribed angle. If I go from the small angle to the big arc, I double it. If I go from the big arc to the small angle, I half it. So if you go one direction, you multiply by 2, and the other direction, you divide by 2. If it's a central angle, it's exactly the same. Remember, chords are inside your circle. Right there, that's theta. So it's the circle with the line through it. I am recording it, so I'll post it. Yeah, if your brain's glitched out, this is a lot. It's a lot even for me, and I'm the teacher. I'll post this video and you'll be able to go back to it. And you have access to the slides too. And then secants and tangents. Remember, secants seek the outside of the circle and tangents touch the outside of the circle. So with secants, I've got an outside and an inside and an outside and an inside. So I need the outside times the total and the outside times the total. Notice you use the outside twice. Outside times the total and the outside times the total. Use the outside twice. With tangents, they touch the circle. Secants seek and tangents touch. These are like the ice cream cones. Anything that meets at an outside angle, those two tangent legs are going to be congruent. So these are like the ones that are between Candace and Brendan up there. We're almost done. I'm so proud. Are you guys like seriously take a second and think about all of the notes you've just taken? This is all the stuff we've learned this year. It's a lot. It's a lot. You should be very proud of yourselves. We ready for the last slide? The sooner we do the last slide, the sooner we'll be done.
Yeah, I have a question.
Okay.
I know find out the question about you.
Mm-hmm.
I know that. It says 360 divided by the exterior angle equals another side.
Mm-hmm.
And after that, you got like the exterior angle.
360, yeah. So 360 divided by the exterior angle gives you the number of sides, and 360 divided by the number of sides gives you the exterior angle.
Okay.
Yep, absolutely. Last two, surface area and volume. I'm going to show you the formula sheet in a minute. You're going to have access to it. I just want you to write this box right here. We're going to look more at this next week, hopefully. I haven't honestly figured out when exactly we're going to do that. It is. So linear dimensions, and that's just like DM, like dimension. Linear things have an exponent of 1. Area has an exponent of 2, and then volume has an exponent of 3. And next week, we're going to learn how we can just convert units back and forth between these two things. So if you go from linear to area, you square. If you go from linear to volume, you cube. And if you go backwards from volume to linear, you take the cube root. And from area backwards, you take the square root. Copy this chart. It's not going to make a ton of sense to you right now. Hopefully it will by the end of whatever day we do it next week. Honestly, I haven't decided which. But definitely take a minute to copy this chart, even if it doesn't make any sense right now. So if I have something that's one-dimensional and I want to turn it three-dimensional, I need to cube it. If I have something that is three-dimensional and I want to turn it one-dimensional, I need to take the cube root of it. If I have something that's linear and I want to turn it into area, I need to square it. And if I have an area and I want to turn it linear, I need to take the square root of it. It all has to do with these powers. And you know this, linear things, radius, circumference, diameter, they're all centimeters, right? Area, surface area, area of a circle, that's all squared. And then volume is always cubed. You know those, you've been working with those for years. Last one is transformations. Just copy this, honestly. When you translate, you slide. If you add to the x, you slide right. If you subtract from the x, you slide left. If you add to the y, you go up. If you subtract from the y, you go down. Reflections or flips. If you flip over the x-axis, so if my x-axis goes this way, I'm changing the y. If you flip over the x-axis, you change the sign of the y because it's moving up and down. If you're flipping over the y-axis, you change the x. It's flipping side to side. So if you flip something over an x-axis, you keep the x and change the sign of the y. If you flip over the y-axis, you keep the y and you change the sign of the x. It just kind of makes sense if you think about it. I'm flipping over a y-axis, it's got to move side to side. If I'm flipping over an x-axis, it's got to move up and down, so I got to change the y. If you reflect over the diagonal, right, this is y equals x, you just switch them. if you reflect over y equals x, you got to switch them. Last two. When you rotate, every time you switch into a new quadrant, you switch the signs. So if you rotate 90 degrees, right, you're going to rotate, you're going to switch the signs. If you rotate 180 degrees, you're going to switch, then switch back. If you rotate 270, you switch back, and then switch again. And then just figure out what the combination of pluses and minuses are for wherever you land. So if you land in quadrant 1, it's going to be positive, positive. If you land in quadrant 2, it's going to be negative, positive. Land in quadrant 3, negative, negative. In quadrant 4, positive, negative. Predict where you're going to go, switch your x and a y, and then apply the signs. Last thing, what math operation do I do for scale factor? Add, subtract, multiply, or divide? Multiply. Say that with confidence. We multiply. Yes, we multiply. Okay? Shake your hands out. I know they're tired. All right. That is our brain dump. Okay? So let me show you what is the rest of our day is going to look like. Okay? You got about 45 minutes to do this or to get started on it. The district post-assessment is right here. I think everybody in this class is freshmen. So this is your next and last practice SOL. It is a grade in the grade book, but it will be curved. Use the cheat sheet we just made and use this formula sheet down here. So if you click on the formula sheet, you'll see it's 2 pages. Okay. The first page is all the formulas you need for surface area and volume. We haven't done surface area and volume yet, so that's why we haven't really looked at it. We'll look at this on Wednesday next week. The second page is, I think, the most useful page. The second page has, I don't know why my computer is not zooming. There we go. The second page has Pythagorean theorem with a right triangle, and it has all your trig formulas with the equations. So sine of your angle is opposite over hypotenuse. It has a picture to show you which one's opposite, which one's adjacent, and which one's hypotenuse. So this is super, super helpful. And it also has a circle formula for the equation. Okay. This second page of the formula sheet is super important. I have not ever seen a quadratic formula question. I do not know why they have it on there. It is not useful for this course. And then at the bottom, if you're ever trying to read a question and you're like, holy crap, I have no idea what it's asking me, go look at this symbols page on the formula sheet and it might give you some insight. Okay, it'll remind you parallel, perpendicular, congruent, and similar. When we start doing surface area and volume tomorrow, it'll remind you what the big B is, what the LA, and what the P are. Those are the 3 big ones, the B, the LA, and the P. Okay. So assignment number 1 is that district assessment. You can either start on that first or start on it second. It is due on Tuesday. The real assignment for today is the circles quiz, the circles quest though. So if you go to that circles unit where you found the cheat sheet, this one is 19 questions. As you have questions on it, you are welcome to ask. I'm going to stop sharing my screen with folks at home, but I will be sharing it on the board here in class. So if you have a question, let me know and we'll talk about it. Okay, this is where I want you to start now. Circles quest, district benchmark, both due by Tuesday. Tuesday. Any questions? All right, let's start. Like I said, as you have questions, please ask them. Yeah, absolutely. If you're in the classroom and you want to use a whiteboard, dry erase marker, go for it.
Sorry.
Hey, hon, how are you?
Good. Happy Friday.
Happy Friday. I know. It's a little tragic. 3. I like that. Exactly what you have on the board is perfect. Yep, I love what you have.
I'm sorry.
Ciao, man.
I mean, if that's impossible to do, if you want to Chick-fil-A by yourself.
It's a lot of Chick-fil-A.
I got 3 things of chicken strips, 2 chicken sandwiches, and a salad.
I've never had
One
chicken
big
salad.
Huh? Why?
I hate it every day. I want
Watch it.
Fries.
their fries.
They're frosted lemonade.
They don't have
Say, anybody have a frosted lemonade?
Guys, can we focus on the test?
Really.
Just saying.
I just hope it- the opposite.
You know how some seniors, they like eat a butter
Mhm.
and or whatever, like my cousin does.
Mhm.
How do they do class? They just have all the classes that they eat directly.
Mhm.
Yeah.
So some seniors can either, if they have enough credits, they can either arrive late or leave early, or some of them like work in guidance, just hang out. This year, for the first time, they let actually seniors graduate in January. So there were about 40, maybe seniors that graduated in January. Mm-hmm. Mm-hmm. Yeah.
Yeah, like my cousin, he gets out of late.
Mm-hmm. Let's stay focused on the test. We should be able to finish the circles test before you leave today. I don't think it should have to be rounded. Which one are you looking at? Question 4 is the easiest complicated question we had yesterday. What relates circumference and diameter?